All right. 2.3. Oh, you're not seeing anything. 2.3. We're talking about, it's got this data set for us. It wants us to find the range, sample standard deviation, range, standard deviation, and interquartile range of that data set. How are we going to do it? We're going to put it in our calculator, huh? We're just going to stick those numbers into L1. You tracking with me? So let's see, can you all see those numbers okay? Let's just put them in L1. Okay, so let me write out what I just said. So for number one, for finding, again, for box plots or standard deviation or mean or median, for any of those kind of things, step one, I'm just going to write it out here for the video as well, stat, edit, enter. Feel free to compare with those around you. See if you're getting the same answers on these. Go to the top. So go to the top. Highlight L1. Press clear. And enter. And then put the data down L1. Pressing enter after each. And then step 4. Stat, go over to calc. And press enter just a bunch of times. And the x bar is the mean, S sub x is the standard deviation. Okay, so what I'm getting, oh, and they want the range too. The range doesn't appear in your calculator, does it? We just have to do that by hand. So how do you, let me just write that out for you. How do you get range? Anybody remember? What's range? Yeah, it's the highest. It's the high minus the low. It's the full range. You know, like if I said, what's the range of scores on after our first exam? Right? That'd be from the lowest all the way to the highest. That's the range. So it's how far from the lowest to the highest. So you just do that one by hand. That one's not hard. So what's the highest score there? Oh yeah, that 98. So the range, the high score is 98. What's the lowest? 22. That wasn't so good. So that would be what? Just use your calculator. 76? That's how far from low to high. We good? So the range is 76. And then it wants the standard. It's kind of hard. It's kind of spaced out weird. Standard deviation comes next, which is, and they want that round to 1 decimal place. So I got, what is it, 28.6? Rounded to 1 decimal place. We good with that? I got standard deviation 28.56. But then they want you to round it to 1 place. Remember how rounding works? You circle the spot they want you to stop at. Right? So they want me to stop right there, right? 1 place after the decimal. Say 1 decimal place. You circle the spot you're going to stop at, and you look 1 to the right. If one to the right's 5 or more, you go up. If it's 4 or less, you leave it. You know all that, right? So that's why I got 28.6. And next comes the IQR. Anybody remember what that? I think we've done that. I can't. What's IQR? Yeah, IQR stands for interquartile range. What is it? Yeah, it's Q3 minus Q1. Remember, yeah, that's right. We did the box plots. Yeah, so we did some IQRs. That's right. That was the last section, huh? That's the width of the box, isn't it? It's third quarter minus first quarter. Now, where are those? Well, they're on your calculator as well. If that same thing, if you just go down, just push the down. If you still have it on your screen, the S sub x and all that, just go down. Oh, I messed mine up. But here, I'll have to do it again. Yeah, just go down, and you'll find, for me, I'm getting the Q3 is, what is it? 83? Thank you. minus 29. Yeah, right? You guys getting that on the calculators? 83 and 29 for the Q3 and the Q1 should be right on the, after you do this stat, calc, enter thing, you should go down arrow. Just go down arrow and you'll find those numbers, right? We did those before. What's that difference there? 54, right? So the IQR is 54. Is that good? Are we happy? Can you crank that out in your calculator? If you just have a cell phone, then download the app just so you can get used to using it while your calculator's en route. All right, so now in the next part, they say, hey, throw in a new number, 122. Add one more number to the data. Somebody got 122 on the exam. So what do we? How? And then basically do everything again. So how do we do that? What do we have to do? It's a piece of cake for us with the TI, right? Just go back into your list again and just put a 122 at the bottom. You don't have to re-enter all the numbers. Just add the 122. Just go stat, edit. Don't clear the old L1. Just go to the bottom of the L1 and add in the new 122. And then stat, calc, enter. You got everything again. So actually we got to do the range by hand. I'm forgetting about that, huh? I'm going to go to a fresh screen here. There we go. No, that's not what I wanted. There we go. So the range, let's do the range by hand. So the new high is going to be the 122, right? High minus low, 122, and the low is still 22. So the range is now 100. We just do that one by hand. But the standard deviation, I'm getting 32.7. Y'all getting that? And the IQR, I don't know what it is. Let's see. It's the IQR, which is Q3 minus Q1, third quarter minus first quarter. I'm getting 87 minus 29. So that's a little different, whatever that is. 50, is that 58? IQR. How we doing? You getting those? Which measure of spread is less affected by the addition of the extreme observation? Now, what did all that fancy talk mean? This last number, remember we had the original data set, and then we threw on 122. Like if that was a test scores or something, that's a very high test score, right? It's an extreme result, extremely high is what they're saying. So when we throw on one more number, an extremely high number, how does that affect? It's saying which measure of spread. Now, what do we mean by measure of spread? We had two measures, tools, statistical things we just calculated that indicate spread. Did you catch them? What they both were? Tell me, yeah, range. Range is one of them. That tells you the spread, doesn't it? High minus low tells you how far apart, high from low. Range is one measure of spread. What's the other measure of spread? Standard deviation. That's actually, remember what standard, we're going to see some tricky questions tonight in the quiz, so we'll talk a lot more about that. Tonight's a good night to really get a feel for standard deviation, but let me preempt it even right now. A standard deviation, like if somebody was just to ask you, you're taking one of them stats classes, what is standard deviation? I mean, we're hitting the buttons, on our calculator and getting a number, but like what is it? Like what's the gut level feel? That's what's most important really, isn't it? You're not going to probably do a lot of statistical studies yourself. Probably most of you not ever do one. But you will read. You will read data, and that's probably the main goal of this class, to make you a wise consumer of data. So if you read something and it says blah, 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 standard deviation is like, what is that? What is the feel of that? Anybody know? Anybody put that into words? Standard deviation.
Average?
Yeah, average what? Average distance from the middle. It's a measure of spread because it's the average distance from the middle. Does that make sense? a little bit, and we'll talk a lot more. We'll see some actual graphs. We'll talk about it a lot tonight when we go through the quiz number 2. So let me just say those words for right now. Standard deviation. Standard deviation is average distance from the middle. You know what I mean? Like if you have for example, if you have a class that you give an exam to, and everybody kind of hits around the middle, B's and C's. If everybody gets B's and C's, hardly any A's, hardly any D's or F's, right? Nobody fails, but nobody aces it either. Bunch of B's and C's, that would have a low standard deviation because there's not much spread. There's not much average distance from the middle. They're all clumped up together in the middle. Whereas if you give an exam and you have a whole bunch of A's, people just aced it, 100% and stuff, and then a whole bunch of D's and F's, and not maybe just 1 or 2 people in the middle with B's and C's. That's going to have a high standard deviation because there's a big spread in the data. There's the average student is far from the middle. They might have the exact same middle. This class and this class might still have an average of, 78 or something. They might have the same middle, but the BCs are real close to the middle, so the average student is not far from the middle in that class. Whereas in this class, with the people that aced it and bombed it, the average student is far from the middle. High standard deviation. So standard deviation, let me just say that word a couple times and help it sink. Standard, that means like typical, average. Standard, deviation. Deviation means distance from the middle, right? If somebody's on a path and they deviate, that means they get off the path, right? Or a social deviant. What's that mean? What's somebody that's a social deviant? Their behavior is not normal, right? Their behavior is deviating from normal. That's the best analogy because that's exactly what standard deviation means. Average distance from the middle. Average deviation. So that's what it is. So anyway, long story short, standard deviation and range are both ways we get a feel for how spread out a data set is. But they come at it very differently, don't they? Range just is high minus low. Doesn't look at any of the numbers in the middle. Where standard deviation is a feel for all the numbers and how spread out they are. So look at what happened when we just did this problem. Let's go back here to the beginning there. So we got a range of 76 for the first data set. And what was our range for the second data set? 100. So I'll write that in 100. So the range went from 76 to 100 when that new hotshot that got 122 on the exam entered the class, right? He or she made the range go up quite a bit. Now, what happened to the standard deviation number? It went from 28.6. That was the old standard deviation. What was the new one? I don't remember. 32.7. So the new one became 32.7. So it went up by about 5 or something, right? 28 to 32, around 4 or 5, whatever. So which number jumped more? The range number? Did it go up more, or did the standard deviation go up more? The range, obviously. Because the range is a flimsy calculation. That's not the word. I forget the word statistic, but that's the feel, that's what matters in the end, right? Range is a weak and wimpy calculation, meaning it's easily thrown off. One hot shot shows up, and boom, now there's a big range from the bottom to the top. Whereas standard deviation it's a substantial calculation. It's more thick and immovable, because it has to do with all the numbers and how they're all interacting. So just one extra hot shot showing up doesn't affect that number a lot. That's what they're trying to get. It's a substantial number. So that's what they're trying to get you to see. Standard deviation doesn't move much just because one hot shot shows up. But range can, if that 22 person just didn't show up to class, they just gave up, and the 122 person didn't come, that would just change the range a ton. Just those 2 people. So do you see how range isn't so much about the whole group like standard deviation is? We're going to go into that feel later. That's what they're talking about here. So which measure of spread is less affected by the hot shot? Which is less affected? Standard deviation, huh? It didn't change much. Well, how much did IQR change? I don't know why they put IQR in there. IQR 54. What was the old IQR? Or that is the old one. What was the new one? 50. Oh, that one haven't changed even less. That changed about 4, huh? Well, that's pretty close. Is it IQR? That I'm not going to push you that hard. That's a stinking picky question. Yeah, because IQR changed 54 to 58. Right? Isn't that the new one? I already forgot. Yeah, 58. That's the new IQR. And standard deviation changed from 28.6 to 32.7, which is 4.1. See how picky they are? I'm not going to push it that hard in the test. So which one changed less? IQR went from, if you can see it down here, 54 to 58, which is going up by 4 exactly. And standard deviation went up by 4.1. So technically, IQR changed the least. I'm just going to ask, well, you'll see what I ask on the quizzes and the practice exams. Yeah.
Will that always be the answer? The IQR will change with each set?
I don't know, to tell you the truth, how random they'll make those questions. Yeah. So just find the IQR change, right? This is 4. And find the standard deviation change, and whichever one's least. Yeah, they could make a data set where it's not. Maybe I should say that. They could make one where it's actually the other way. I don't know if they do or don't. All right, we better move on. Other questions? Number 2. So let's just do the range. Range is always by hand, so I'll just do that much. Range is high minus low. What's the highest score up there? 10, right? Unless I'm missing something. And what's the low? 1? So the range is 9, huh? Range is 9. Standard deviation, I'm just going to write calc. Just put all this data in your calculator in L1, hit the buttons, and you got it. Let's move on, if you're good. All right, question 3. 4-unit class like stats. Students should spend an average of 12 hours studying for the class. I think a statistics professor wrote this question. The one who wasn't me, actually. I'm just getting these from the previous. I think it's Mr. Jameson. Yeah, right. Jameson. Yeah. Anyway, I think he made a lot of these. For a 4-unit class, I actually got him from Lake Tahoe Community College, I think. Anyway, whatever. You don't care. 12 hours of studying for the class. Right? Remember the old college rule: 2 hours out for every 1 hour in. Blah 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 blah. So 12 hours. A survey was done with 30 students, and the distribution of total hours per week is bell-shaped, with a mean of 14 hours and a standard deviation to 2.5. All right. Have we talked about bell-shaped curves at all? No, not at all?
No.
Okay, because I'm also teaching stats somewhere else, and I forget what I've said in which stats class. All right, let's talk about it. So question 3, bell-shaped. This is a huge deal in stats. In fact, we're going to have whole chapters on this. They're just getting our feet wet right now. Bell-shaped distribution is also called normal distribution, because it's what normally happens for naturally occurring phenomenon. All right, let's take a look. So what is it we're talking about? Well, if you wanted to measure anything, almost anything you want to pick, not anything, but anything occurring naturally. Like if I wanted to measure men's shoe sizes, let me just pick something at random. What's the average men's shoe size? I have no idea. Maybe 8. Pick a number. So maybe the average men's shoe size is 8. Not every man has the average size feet. Some have, 9, 10, 11, 12, 13. What's the biggest feet people have? I mean, 14. Regular people. 14, 15, something like that. Not many people have 15. Is that true? I don't know. I don't have size 15 feet. And then going down the other end, there's smaller feet, of course, right? I don't know what the smallest. Anyway, my point is, if we just went all over the city and just asked people at random, hey, at random, there's a men's shoe sizes down here. Men's shoe size. What shoe size do you wear? Just wrote it down, collected a bunch of data. What we would find is most people are average, so we'd find this big hump in the middle. Right? That's where the bell comes from. What this means is most people are average. You'd find the most amount of people average. And then as you get to really, really big feet or really, really small feet, you're not going to have many people. There's some, but there's not many. Right? So the curve comes down in both directions. That's what you would find. There's the average. Most people are average or close to average, maybe a little bigger, a little smaller than average. But then there are some people with really huge feet and really, really tiny feet. Right? On that? Now, not just men's shoe sizes. So that would be called a normal distribution or a bell-shaped distribution. But it wouldn't just be that way for men's shoe sizes. If I wanted to go, let me see, what if I wanted to go out there to the grass all over campus and pick up snails? That'd be kind of gross. But just pick up a bunch of snails and do a big old biology experiment where I bring all the snails in and I weigh them really carefully on the biology scales that are real accurate, that we have here on campus. There'd be some average snail weight. I have no idea. I'm going to make up numbers here. Maybe it would be 6 ounces, right? And there'd be some snails that are bigger. There'd be some snails that are smaller out in the grass all over campus. We've gathered like 100 snails. So I'm just showing you it's anything occurring naturally. And we'd find, guess what? A bell curve. They would be normally distributed. Pretty much everything that occurs naturally is bell-shaped, normally distributed. Meaning, whatever the average is, most snails, most mittens shoe sizes are average. Some of the snails would be a little smaller than average, some a little bigger. And now the really huge snails, there wouldn't be many of those. The curve goes way down. And the really, really tiny snails, there wouldn't be many of those. The curve goes way down to the extreme values. That's, again, a normal distribution. Now, so you get the idea, right? Anything naturally. IQ scores on SAT exams, anything. You pick it. This just occurs all the time. We're really into this. It's really important in statistics. We'll have whole chapters on this. Now, let's get specific. What we mean by, most things are normal is within, there's 68% of all the snails would be from, right here, this is the middle, right, the mean. This is the average snail, right in the middle. And this number, let me get the word snails out of the way here and put stuff down here. Again, this right here in the middle is the mean. And this spot is the mean plus 1 standard deviation. SD stands for standard deviation. This spot here is the mean minus 1 standard deviation. So remember what standard deviation is. Typical distance from the middle, right? Not everybody's average. Some are higher, some are lower. But how far are they from the middle? Typically. Standard distance from the middle, deviation, right? So if I said the average snail out there in the grass weighs 6 ounces. That's the mean. And the standard deviation is 1 ounce, let's say. What does that mean? Standard deviation is 1 ounce. Meaning the typical snail is off of average by 1 ounce. Some are way bigger than average. Some are just a little bigger than average. Typically, they're 1 ounce off of the middle. They deviate from the middle, on average, 1 ounce. That's what that standard deviation means. So you would find that 68% of all snails would be between 5 ounces and 7 ounces. And these are the numbers they're wanting us to use in this problem. And then if you went further, if you went 2 jumps to the right, we're starting in the middle here. Now we're going 2 jumps right and 2 jumps left. If you go 2 jumps right and left of the middle, you're getting even a bigger chunk of the snails. How much? 95%. And it's not just for snails, it's the same numbers for the men's shoe sizes. You would find that 95% of all the snails would be between 4 ounces and 8 ounces. You'd have almost all the snails. Would be between 95% of them will be between 4 ounces and 8 ounces. What is that 4 ounces number? That's the middle, the mean, minus 2 standard deviations. And what is the 8? That's the middle, the mean, plus 2 jumps. 2 jumps to the right, added to the middle, right? So if you're going from the middle, 2 jumps back, 2 jumps to the right, in that zone, you'd find 95% of all snails. Finally, last number in this, if you went 3 jumps right and 3 jumps left, you would find 99.7% of all snails would be between 3 ounces and 9 ounces. What is that number? That's the mean plus 3 standard deviations, and that's the mean minus 3 standard deviations. So from the middle, if you went 3 jumps left and 3 jumps right, you would get almost 100% of the snails, 99.7% of the snails. These 3 numbers are called the empirical rule. What does empirical mean? That's a valuable word to know, getting a college degree. If you read things and somebody says empirical evidence shows, what does that really mean? Empirical evidence or empirical data, empirical rule. Does anybody know? You don't want to be college educated and not know that word. That's a word professionals will expect you to know. Empirical means from hard data, meaning somebody didn't just think off the top of their head. Hey, I just feel that there's a lot of snails between 3 ounces and 9 ounces. No. Empirical means from data. From hard fact, meaning we went out and grabbed snails and measured them. That's what if somebody says empirical data shows, that means they took data. They're going from actual numbers, not just theorizing. Does that make sense? That's empirical in any setting, means that. So in the statistical world, when they say empirical rule, they mean the numbers for things normally distributed are these 3 numbers. So if I went back to the men's shoe size example, and I said, okay, I was just making up, the average man's shoe size I said was 7. Oh, I said 8 at first, didn't I? I changed it, huh? Whatever. Let's just say it's 7. Let's say the average man's shoe size is 7. And let's say, so the mean, maybe that's a little small, but whatever. The mean for men's shoe size, let's say, is 7. And the standard, let's say it's 2. I'm just guessing. I have no idea. You could go on Google. Anybody got Google? You guys have Google, right? You want to tell me what the real number is? Yeah, here, let's take 2 seconds. Okay. So the mean is 10, it's really 10.5. And I'll just say standard deviation is 3. I just want to make the numbers easy. So let's say the mean is 10, the average man's shoe size is 10, and the standard deviation is 3. So if I write all these shoe sizes here, I'm going to need to put more marks here. Let me try to fix my curve. So the average is 10. I'm going to go 11, 12, 13, 14, 15, 16, 17, 18, 19.
1.5 for standard deviation. Like a size and a half.
Oh, really? Yeah. So we getting different for America or for the world?
America.
All right, yeah, let me fix this. Thank you. That did seem crazy big. Yeah, that clarifies. All right, so yeah, it was whatever it was, inches, but so I'll go by 10.5 and 1.5 is the standard deviation. So I'll go back to the real numbers now. So 10.5 is the average man's shoe size. Okay, and so I'm going to go, so that's 10.5. This is going to be 10 right here. Wait. I'm running out of room. This will be 10, 11, 12, 13, 14. This will be 9, 8, 7. So I want to make this real for you. So 1.5, 4.5, 6, 15. Okay, so let's do it. So that means, if that's the case, bell-shaped for men's shoe size, we got real data now. For the USA, the average man's shoe size is 10.5, and the standard deviation is 1.5 as far as size, not inches, size. Okay, so that means if the middle is right here at 10.5, then if I do one standard jump above that, where am I going to be at? If you go 10.5 and you add 1.5, if you have $10.50 and you add $1.50, you got $12. So we're at size 12. That's going to be one standard to the right? This is the middle mean plus one standard deviation. It deviated from the middle, one standard amount. The typical amount. That means 1.5. Not every man is average, right? Not every man has exactly 10.5, 10.5 shoe size. Men are off of that. The typical man is off of the middle by 1.5 shoe sizes, either above or below. So some are way above, some are just a little above. But the average man is off the middle by 1.5 shoe sizes. That means that's what that means. Okay, so then if I go up one standard amount and I go down one standard amount, I'm at 9, huh? $10.50, subtract $1.50, you're at 9. So that spot is the mean minus 1 standard deviation. So that's middle, add 1 standard deviation, subtract 1 standard deviation. What percentage of all men are going to have a shoe size between 9 and 12, therefore? Same percent. That's the great thing about the normal curve. The numbers on the bottom change from example to example. Snails, men's shoe size, whatever. But the percentages remain the same. That's what the normal curve means, the bell curve. It means these fixed percentages, these empirical numbers. So now if I go another standard deviation jump to the right, I'd have to go another 1.5, huh? So if I'm at 12 and I go another 1.5, where am I at? 13.5, 13 and a half. That's the mean plus 2 standard jumps. And if I'm at 9 and I jump back another standard, where am I at? 7.5, right? That's the mean minus 2 standards. So what percentage of all men in America have shoe size between, what is that? 7.5 and 13.5? Same, 95. Same thing we got for the snails, right? Same day, same 3 numbers. 68, 95, 99.7. Anything that's bell curve distributed, which is almost everything occurring naturally. I'm sure snail weights are, even though I don't know what their actual average is. But men's shoe sizes, I am quite sure, are normally distributed. And you guys got the real numbers, so I'm sure that 95, very close to 95% of all men have a shoe size between 7.5 and 13.5. Who would even care about this? Yeah, shoemakers. What sizes should they make? Should they make a bunch of size 15s? No. I mean, right? They're going to, 95% of the public that's going to buy their shoes is going to have between 7.5 and 13.5. Huh? They need to know where people are at. And then one more, let's finish one more standard deviation jump. So if I'm at 7.5 and I jump back one more standard amount, 1.5, where am I at? 6, right? That is the mean minus 3 standards. And if I'm at 13.5 and I jump forward another 1.5 shoe size, I'm at 15. That is the mean plus 3. We already did 2. That's 3. That's 3 standard jumps. And what percentage of all men will have a shoe size between 6 and 15? 99.7%. That's almost all men. There's hardly any men that don't have a shoe size between 6 and 15. So he might have a shoe size bigger than 15, but it's very rare, right? Almost everybody will be between 6 and 15. 99.7% of all men. All right, anyway, you got the idea of the bell curve. We'll have whole chapters on it later. Let's get back to the question. So they're talking about hours people study statistics. They asked 30 students. They say it's a bell-shaped distribution. The mean is 14. So I'm going to draw a little curve down here. Well, yeah, let me draw a curve somewhere we have some room. I'm going to draw another bell curve. All right, here we go, another bell curve. What's the middle? This is for the students' hours of studying. So what's the average? 14 hours. I'm not sure I believe that. But anyway, that's what the example says. 14 hours is the average amount of studying. And what is the standard deviation? 2.5, right? Y'all with me? Making sense? So 14's the middle. And the jumps are going to be 2.5 each, aren't they? So the middle's 14. That's the mean. That's the middle of the curve. And the jumps, the standard deviation is 2.5. So I'm going to go one jump. Now if you go, let me do it this way. Forward. If If you add 2.5, where you at? If you're at 14, you add 2.5, you're at 16.5. If you subtract 2.5, you're at 14, you take away 2.5, where you at? 11.5, right? What percentage of all students, if this data is really true, would study between 11.5 hours per week on stats and 16.5 hours per week on stats? That includes in-class time. 68%, right? If it's normally distributed, bell-shaped, that means 68% are within, from the middle, one jump back, one jump forward. And then let's do another one. Let's go another jump now, another 2.5. Add 2.5 again. Subtract 2.5 again. You're going to get, what's 16.5 plus 2.5? 19. Subtract 2.5 is going to be 9. Yeah, 9. So what percentage of all statistics students study between 9 hours and 19 hours? 95%. Finally, one more jump to the right. Another, you just keep doing the same standard amount, right? 2.5, that'd be 21.5. And then another jump to the left of 2.5. Subtract, that'd be, what is that, 6.5? So, and then you'd get 99.7% of all statistics students study somewhere between 6.5 hours and 21.5 hours per week on their stats work. Let's go back then. So the answer, they want those two, and those two, don't they? Those are the ranges. Everybody see what I'm saying? So from the middle, one jump right and left, that's the 68% number. They want the 11.5 and the 16.5. So 11.5, 16.5, right? 68% of all stats students would go between 11.5 and 16.5. And 95% would go from here at 9 to here at 19. 9 to 19. And finally, 99.7 would go from here at 6.5 to here at 21.5. 6.5 to 21.5. There we go. Question?
Can you put it back?
There it is. So question number 5. Give me a bunch of data. They want mean, standard deviation, blah, 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 blah. You know, put it in your calculator, right? Take this data, put it in L1, hit the button, same old, same old. So I just want to show you the one new part, which is coefficient of variation. What that is S sub x, standard deviation, which calculator will give you, over x bar times 100%. Or I'll just write change 2%. Change 2%. How about I just write it that way? So use your calculator. It'll tell you S sub x and x bar. So let's do it. Here's what I'm getting. I'm getting a mean. Remember, the mean is x bar, right? I'm getting 25. This says 2 decimals. This is 25 point. I'm just going to write 425. And then standard deviation, S sub x, I'm getting 8. Can't see it very well. 8.5309. Anyway, I'm using too much accuracy on purpose because, I don't know if you know this, but if you're going to use a number in a future calculation, then you need to use more accuracy so you don't get the final one wrong. Let me say that again. If you're going to use, down here I'm going to have to use S sub x and x bar. Use a number that's not rounded too abruptly. So here we go. So S sub x, for coefficient of variation, S sub x is this number, right? 8.5309 over x bar, which is that number, 25.425. And then hit the buttons on your calculator.
So when it asks us for the coefficient of variation on homework, do
want us to do it for.
Yeah, you want to use more. I'll explain the whole thing. So I'm getting 0.3355. Oh, it just wants a whole number? Oh, well, yeah, but wait a minute. Hold on. We haven't changed to percentage yet, right? I'm getting 0.3355. And then how do we change that to percentage? Two places, you know quite well. 33.55%. Now round that to a whole number percentage. What would that be? 34%, huh? Now for these other numbers, they want them rounded to two places. So this should be 25.43, and this should be 8.53. Yeah, so eventually you do want and need to put in rounded numbers. But I'm saying when you use them, when you use a previous rounded number in another calculation, make sure you use more accuracy. Is that making any sense? Because if you use this rounded number, it might throw off the final one too far. It might not. It might be fine. But I don't want you to waste your time and get frustrated. So just to be sure, if you're ever about to use in another calculation a previously rounded number, in general, in math and science, it's always best to use more decimal places. Use the number before you rounded it, in other words. So always use the number before you rounded it. Use more accuracy if you're going to do a future calculation. Questions I can answer on this one? Yeah.
How do you round if it's like 10.99?
So you got 10.99. You mean the final answer, the percentage for the coefficient of variation?
No, it was the standard deviation. It came out to 10.996.
Oh, standard deviation came out 10.996. Yeah, good question. And they want, let's do this together. What if you got standard deviation of 10.996 and they say round to two places? So remember what you do. You circle the place you're going to stop at and look one to the right of that. I'm going to stop here, two places past the decimal. Look one to the right of that. If it's a 5 or more, up you go. So how do you take 10.99 and go up by 1? 11.00. Right? Isn't $10.99 add 1 cent, $11? Does that make sense? Right? Isn't 10.996 closer to 11.00 than it is to 10.98? Those are the two options, huh? Or 10.99 even. I'm sorry, those are the two options, right? We're saying, does 10.996 round closer to 11.0 or 10.99? It's only 004 from 11, huh? It goes up to 11. Does that make sense? So you just circle the place you want to stop at. Look one to the right. If it's 5 or more, that has to go up. Maybe I should say it that way to be more clear. Right? That has to go up, meaning add 1 to it. So again, circle the place you're going to stop at. Look 1 to the right. Then you got to add 0.01. So it's so it's 11.0. So that would round to 11.00. Good. Other questions I can answer? Coefficient of variation. So we're on number 6. And we're talking about z-score. All right. Well, basically, this is a very good example for getting the feel what z-score is. So let's say, so it's saying the average man, so for men, the average, or the mean, same thing, the mean, whoops, write that. The average man, the mean is 69.8 inches tall, and the standard deviation is 2.68. So there's the average, and there's how much they're off the average, right? And then for women down here, the mean, the average woman is 64.6 inches, and the standard deviation is 2.54. Okay, so now what they want us to calculate is the z-score. What's the z-score? Well, basically, what if this man is 6 foot 3 inches tall? Is he tall for a man? Average? What average they just said was 69.8? How much is, man, we better be clear on that. What is 69? What's 70 inches? What's 6 foot? 72. Right? 6 foot, 6 times 12. Right? 72 inches would be 6 foot. So they're saying if the average man is 69.8, the average man is under 6 feet. couple inches under 6 feet. Right? That's about 5'10". Right? The average man's about 5'10", they're saying. Does that make sense? Right? This is about 70, which is 2 less than 72, which is 6 foot. So it's about 2 inches less than 6 foot. So 5'10". They're saying the average man's about 5'10". That's what they're saying. 69.8. So therefore, back to this question: is 6'3" tall? Yeah, he's taller than average. Let's go down to the woman now. So that man's taller than average. The woman, she's 5'11". What's the average woman? 64. I don't even know. What is that? 5 foot would be 60 inches, right? Because 5 times 12. So that's 6. So this is 5 foot and then 4.6 feet, right? 4.6, about another half foot. It's 5.5. She's about 5.5. So the average, they're saying the average woman is about 5.5 feet. Does that make sense? When it's 64.6 inches, that's 60 inches, right? 5 feet, and another 4.6, which, well, that's not quite a half a foot. It's more, whatever. I'm tired of fiddling with it. Is this 5'11" woman tall? Yes. But who's taller? Well, in an absolute sense, of course, the man is. He's 6'3". But who's taller for their group? So that's what we want to figure out. Is the man taller compared to other men, or the woman compared to other women? Which person is taller for their group? Which is taller for their group? So how do you compare like two totally different groups to figure out like where somebody sits? I mean, they're both tall. For men, he's tall. For women, she's tall. Like if they're going to get married, this is the man, he's tall. This is the woman, she's tall. For women, who's really taller for their group? Who's really going to contribute to the kids being tall more? Is he more dramatically tall for men, or is she more dramatically tall for women? Well, we have something to figure that out called the Z-score. It's a measure of how you are in the group you're in. That's what Z-score is. Let me go to a fresh screen here, and I'll write the formula for you. So Z-score. Oops, I don't have room there. Right down here. So Z-score equals your score minus the mean, the average, divided by the standard deviation. That's how you do Z-score. So let's do it for the man first off. Let's find the man's Z-score, and then we'll find the woman's Z-score, and whichever one's bigger means they're taller for their group. It's comparing you within your group. So here we go. For the man, he was 6'3" tall. Now they're tricking me here. I got to change that to pure inches because the other numbers are in pure, not this foot inches mixed stuff. I got to change it to pure inches. So 6 feet is 6 times 12, isn't it? Add 3. It's going to come out 75 inches. That's how tall he is. 6 times 12. Right? 6 times 12, because there's 12 inches in every foot. He's 6 foot tall. 6 times 12, add 3. He's 75 inches tall. So his score is 75 minus, what's the mean, the average for men? 69.8. And the standard deviation for men? 2.68. So now, can you guys all take out your calculators and do this real quick? Because I want to show you there's a right way and a wrong way to do this. In fact, let me just write it for you. If you just type in 75 minus 69.8 and go divided by 2.68, you will get the wrong answer on that. That will be the wrong answer. Now, why? Rather than just say, don't do that, that's bad, don't be bad. That won't be very helpful to you. Let me try to reason with you to think like the calculator operates. So, why is it that, isn't that what this says? Subtract them and then divide. What's the problem? What's the calculator's problem?
Order of operation.
Yeah, order of operations. It's doing the divide first. If you type this in, what the calculator thinks you mean is this. It's going to divide the last two like that. And you mean the whole thing is over. They're both together divided by the 2.68. It'll only divide the last number by 2.68. Does that make sense? So how do you get around that? You either do parentheses, but those can be a pain. I mean, you can do it, though. If you want to just put parentheses, that'll work. Or you just make sure you hit enter before you hit divide by 2.68. Because when you hit enter, you're saying, do that part now, calculator. And then it'll do the whole top, and then divide by the 2.68, and you'll be good. That'll do it right. So remember that? That little stuff gets people on the exams a lot. So make sure you pay attention to that and practice that. So I'm getting 1.94. What do they want? 4 decimal places. Okay, 1.9403. You want 4 decimal places. Did you guys get that? 1.9403? Making sense? Let's do the women's z-score now. For the woman. And by the way, what does that 1.94 number mean? Let me give you a feel for that. That means the man is almost 2, right? 1.94 is almost 2. Almost 2 standard jumps above average. He's quite a bit above average in height. He's not just average. He's not just the typical. That's standard deviation jumps from the middle. That's what z-score means. This man is twice the typical amount above average. Right? Because 2.68 is the standard deviation. He's almost twice that. Z-score 1.9. What z-score means? Let me write it down here for you. Z-score is number of standard deviation jumps from the middle. That's the feel. Okay. Notice with these statistic formulas, there's the actual formula, and then there's the feel. I'm trying to give you both as we go. Both are important. Probably the feel is really even more important. Because you're not going to calculate this stuff in your real life. Computers will do it, but you'll read. And so you want to understand the feel more than anything. Number of typical jumps from the middle. So that man is 1.9403, almost 2 full jumps above average. He's quite a bit taller than the average man. Almost 2 full standard jumps. Okay, let's come down and finish up the woman calculation. So same formula. Score minus mean over standard deviation. You're going to put all these in your 3x5 card. We'll talk about that on Wednesday. Basically, I'd make the 3x5 card as you do the practice exam, because that will show you exactly what's on the real exam. So as you go through the practice exam, we'll do it on Wednesday. Anytime you need a formula, put it on your 3x5 card to have it for the actual exam. That way you know you got everything you need, because everything's on that practice exam. So that's the best way. All right, so score minus mean. What was the woman's height score? 5'11". Got to make that pure inches, don't we? So 5 times 12, add 11. 71. She's 71 inches tall. 71 minus the mean. What's the average woman? 64.6. Divided by the standard deviation for women? 2.54. So just put that into your calculator. Make sure you hit enter when you're done with the top before you do the divide, right? So that it doesn't just divide the last number, but it divides the whole subtraction, the whole total. So I'm getting 2. Let me write here. I'm getting 2.5197. It was 6.8, so it rounds to 7. Let me write it here. 2.5197. So, yeah, you all were right. That woman is more tall compared to other women than that man is. She's more than 2 full jumps above average for women. She's an Amazon woman. Right? She's just super tall. For women, that's super tall. That's 2.5 jumps. Remember the jumps we're talking about the curve jumps. Remember, 95% of all people are within 2 jumps, aren't they? Remember? Try to connect that with what the curve. Remember, 95% of all people are 2 jumps back, 2 jumps forward. So if you're beyond that, you're a freak, so to speak, right? She's freakishly tall, right? She's in the 5% category. Only 5% of people are that extremely tall or short. Is that making sense? Where he's not quite a freak. He's not quite more than 2 jumps. He landed just within the 2 jumps. Everybody see that? So she's taller for women than he is for men, is the answer to that question. So what do they ask? Who is relatively taller? The woman is, compared to other women, than he is compared to other men. We good? Question 7. Temperatures in June in Paradise City are distributed nearly normally with mean and standard. So which of the following temperatures would be considered unusual? Unusual is the word I just said, freakish. Meaning way off the normal. Freakish specifically, mean plus 2 standard deviations or mean minus 2 standard deviations. So if you're more than 2 jumps off the middle, let me write it that way. More than 2 standard deviation jumps from the middle, from the mean. That's what we mean by unusual. It's actually, they're saying it all casual, but it has a more formal meaning. Unusual is like freakish. So that'd be like the woman. She was more than 2 jumps above average in height. Whereas the man, he wasn't quite into that unusual zone. His height is still kind of typical. He wasn't quite 2 jumps above average. He's tall, but not freakishly tall. She's freakishly tall because she's more than 2 jumps from the middle. So that's what they're asking us here. Which of these temperatures would be freakishly high or freakishly low for Paradise City? Well, we got to figure out what the limits are on freakishly low and freakishly high to figure that out. So what's the mean? There it is, 84. So 84, 80, all right here, plus 2, what's the standard deviation? 6. 84 plus 2 times 6. Right? Or how about I just go 84 plus 6 plus 6? That make sense? 84 plus 6 plus 6. What is that? 96 degrees, huh? And here I'll go 84 minus 6 minus 6. Minus 12, what is that? 72. So as long as you're between 72 and 96, you're not freakishly high or low. So are any of those temperatures outside that region? Yeah, only the 99, huh? That's a freakishly high temperature for Paradise City in June. Very rare. Does that make sense? What we're doing there? So we're talking about that normal curve thing again. The middle, add 2 standard jumps, and the middle, subtract 2 standards. 95% of things are in that zone, aren't they? So if you're more than 2 above or below, you're freakishly high or low. We call it unusual. Seems like too casual of a word. All right. So number 8. It's another z-score problem, but it's going to be harder because you have to solve it backwards. Adult men have heights with a mean of 69 inches and a standard deviation of 2.8. Find the height of a man with a z-score. So write out the z-score formula. We're going to do a little algebra here. Are you ready? I don't know what your algebra background is. I'll do it. I got to do it quick because I really got to get to that quiz for you. So the z-score formula again. Mean minus standard deviation. No, that's not it. Score minus mean over standard deviation. Okay. Now, this time the funny thing is they're giving me the standard right here. They're saying, I'm sorry, this is the z-score. The z-score, there it is. They're telling me the z-score is 2.8929. So that's the z. Okay. The mean, 69. That goes back here, right? The standard deviation, 2.8. So the only part I'm missing is the score. And that's what they're asking me. Find the height of the man. Find his height, his score. So why don't we just call that x, and you need to solve the little equation for x. We won't do a lot of this, hardly any algebra. This is, I think, the only one we'll do in this first exam. So, all right, so we have to solve that little equation for x. Does anybody remember how you do that kind of thing? Yeah, we got to get it alone. Yeah, the equal sign is like a separator, and x is saying, I want to be alone over here. Get rid of all this stuff so I can be alone. That's what it means to solve for x, right? Yeah, I think the easiest thing I found for students over the years is just to put this over 1, right, because it didn't really change anything, and cross multiply. Diagonal, diagonal. Or you could just multiply both sides by 2.8. It's the same effect. Either way you like better. So I'm just going to cross multiply, but if you're familiar and you're thinking, can we just multiply by 2.8? You're right. That's the same thing. So when I say cross multiply, I mean these guys will multiply. So 2.8929 times 2.8 equals, and then on the other side, these guys will multiply. 1 times x minus 69. So use your calculator on the left. I have no idea what that is. 2.8929 times 2.8. I'm getting 8.10012. And the other side, 1 times x and 1 times 69 doesn't do anything. Right? Multiplying by 1 changes nothing. Right? 1 times x is just x. And 1 times 69 is just 69. I just distributed the 1. Remember distribution? Maybe, maybe not. You just take that 1 outside the parentheses and multiplies both those guys inside the parentheses. Last step, x is saying, I want to be alone. Get rid of this minus 69 so I can be alone. Add the 69. Yeah, you always do the opposite. So you add the 69. Whatever you do to one side, you have no choice but to do the same thing to the other, right? If they were equal before and you treat them the same, they got to be equal after, don't they? It's called the property of equality, right? If those two sides were equal before and we add 69 to both of them, they got to be equal after. So the answer then is 77.10012. So what's the man's height? It's that answer right there. They want 4 decimal places, so I'm going to say 77.1001. I'll stop right there because they said 4 decimal places. All right. Questions on that? Okay, let's take a look here. This is number 13. So, mean, median, mode. Yeah, let's just do mode. I heard people talking about mode. You remember mode? Mode's the one that occurs the most. Remember that? I'll write that for you. Again, mode is number that occurs with the most, meaning highest frequency. Remember that? Number that occurs the most. Like if we wanted average shoe size, we would mean the shoe size that occurs the most. So this is a frequency table. So what's new on number 13 here? This is a frequency table. What does this mean? This means there's 30 44s. And there's 25 45s. And there's 22 46s. And there's 17 47s. And there's 10 48s. Remember, frequency means how many. How frequently does the number 44 occur? Is this making sense, kind of? If I wanted to write it out, I'm not really going to. But if you wanted to see the actual data, you would write 44. Don't write this down. But I just want to make sure you feel, you picture in your mind's eye what's happening. 44, 44, 44, 44, blah, blah, blah. A whole bunch of, how many 44s would there be? 30 of them. Right, you're getting it, etc. Does that make sense? Frequency is how many. So they're telling me there's 30 44s and none you go. Well, how? And then they're asking all the typical stuff. Well, first off, what's the mode? We'll do that by hand. We always do mode by hand. Yeah, the one that occurs the most, what number is there most of? Yeah, 44. You guys are right on. Good. 44, because there's more 44s than there's anything else, huh? So that would be the mode. Okay. Now the other two, mean and median, we got to do with our calculator. And so how do we do this with our calculator? Basically, I haven't shown you this, but it's not much different. It'll be pretty quick. It's just you got to put this data set in L1 and this in L2. So these guys down the L1 column, these guys down the L2 column. So you got to use both L1 and L2 when they give you a frequency table. So let me write that. For a frequency, in fact, let me go to a fresh screen here. For a frequency table, what number is this? Number 13? Well, I should put it here where you can see it. For a frequency table, L1 and L2. L2 has to be the frequencies. You can't switch them. You got to have L2 be the frequencies, which is great. That's how it's already set up, so no problem. So step 1, put L1 and L2 in the frequency. Put all the stuff in the data and the frequency in L1 and L2. And then step 2 is what we normally do with one small wrinkle. Hit Stat, go over to Calc, hit Enter, and don't hit Enter. Here's the wrinkle. You've got it depends on your calculator whether you have an old one like I do or a newer one. You're either going to go L1, L2, or if you have the kind that asks you for list and frequency list, the newer kind, which a lot of you have, that's L1 and L2 there, and then hit Enter. That's the difference. You got to give it L2, you got to give it L1, L2 if you have the old kind of TIs like mine. Or if you have the newer kind that asks you for list and frequency list, it's L1, L2 on separate lines. If you have the old kind, it's L1, L2 on the same line. And then hit Enter. How do you get like an L1 or an L2 to pop up on the screen? The second button in the upper left-hand corner, that blue second button, you've got to hit second and then 1, just the number 1. Just hit second and then the number 1. That'll pop in an L1 for you. And then for the L2, it's the same thing. It's just second and the number 2. And it'll pop in an L2. We'll use that throughout the semester. So second and the number 1, that's L1, and second button followed by L2. I'm sorry, by the number 2, and that'll give you an L2.
When do we do that? Before or after?
That'll make this L1. So it depends on your calculator. If you have the kind that says list, then you got to make an L1 appear here by hitting second and 1. So it depends on your... I got X bar 45 point... one decimal is 45.5. And the median, you have to roll down to get median, 45. So it should be, so let me write this better here. So it's stat, calc, and then it's one variable, in other words. Stat, calc, just one var, and hit Enter, and then L1, L2, or if you have list and frequency list, it'll be L1, L2, and how you get L1. L1 comes from second and 1. And L2 comes from second and 2. Second and 2. That's how you get L1. That's how you get L2. Okay, so number 18. Which statistic, mean, median, or mode, is most appropriate? Okay, mean, median, or mode. Yeah, that's a good question. Okay, so the tables in the dining hall are numbered 1 through 12. The principal calls out a number for a table that will go through the buffet line first. The other tables follow in order of the table numbers. One student is sure the principal calls certain tables more often. More often? Mode. It's how often the numbers occur. Next one. Offensive line of football team is larger than in previous years. That's got to be mean. They just added them up and divided. Next, reporter is doing a story on the falling prices of houses in large neighborhoods. Reporter wants to demonstrate how the prices have fallen. Typical, that's median. They always use median. Remember I said for house prices and for salaries. Numbers that are really big and really small, they always use median because that isn't affected by high and low. So number 19, it's the same thing. I just want to show you. Basically, this list in the top is going to be your L1. Remember, the frequencies are L2. Just put them in your calculator, hit the buttons. And then at the bottom, so I'm going to solve this is just off your calculator. And then at the very bottom, they ask a couple tricky questions. What percent of the respondents have at least 8 pairs of shoes? What percentage have at least 8 pairs of shoes? Well, 11 people have 8 pairs of shoes. See what the data is here? It's number of pairs of shoes that different people have. That's a crazy number of pairs of shoes, in my opinion. I've got like 3, but my wife's got like 50, so, we kind of average out. So, 8 pairs of shoes. 11 people have 8 pairs of shoes. 9 people. Oh, no, I did that backwards, huh? Let me try that again. 11 people have 8 pairs of shoes. 8 people, right? Frequency, that's how many? Have 9. 11 people have 10. 8 people have 11 pair of shoes. So they're saying what percentage have at least 8? That means 8 or 9 or 10 or 11, huh? At least 8? If you have at least 8 pair of shoes, you got 8, 9, or 8 or more. At least 8 means 8 or more. So if you got 8 or more, 8 or 9 or 10 or 11, then what does that mean if you have 8 or more? How many people have 8 or more? 11 plus 8 plus 11 plus 8, which is 38 people. 38 people have 8 or more pair of shoes. How many total people in this study? I don't know, whatever all these frequencies add up to be. 21, 31. Oh, it said, yeah, it's right there. I don't need to add them up. Yeah, thank you. 69. Yeah, it just says 69. So that means 38 people out of 69 have 8 or more pair of shoes. See how I came up with that? I looked at the 8 or more, how many people, added those up. Let me get rid of this stuff. 38 people out of 69, hit the buttons on your calculator. I'm getting 0.5507. You got to make it a percentage. Move it 2 places. 55%. Do they want a whole number? No, they didn't say. Oh, 4? Like even all those numbers? Well, I'll let you figure out what they want there. I don't know. I got to move. 73% of all respondents had fewer. Yeah, so the other one's the same.